I'm recording this video because since you were testing and there were two lessons that I couldn't teach to the class, I'm gonna use this video as the makeup lessons so you don't have to miss the instruction to move forward to the next topic. Since you don't have me in the class today and you're not learning a new topic, I'm expecting you to complete two worksheets that were assigned during the last week. The one that was addressing temperature conversions and the one and the understanding main idea assignment that was posted in Schoology as well. So I'm going to use this video to explain both topics. I'm going over temperature conversions and I'm going to review dimensional analysis one more time, and then I'm going to address significant figures and percent error. Okay, after this video you have to be able to do the two assignments by yourself, because on Thursday I'm going to review whatever we have done until today. You're going to complete a practice test and then you have your test. Over here your degree Fahrenheit. Okay, so I'm going to start with reviewing temperature conversions. Okay, by the way, I don't know if you have read the updates in Schoology. I have posted over there the day that you have the test, plus all the objectives that are gonna be assessed. Since temperature conversions follows on the conversions, you're gonna find this topic in the test that you're taking this week. Now, why do we have to convert the temperature? We have to convert temperature because the metric system is the system that we use to communicate data within the scientific community. And you know that mass is gonna be expressed in grams, kilograms, centigrams, or micrograms, okay? You know that volume can be expressed in liters, kiloliters, centiliters, microliters, okay? And you know that length is gonna be expressed in meter, kilometers, centimeters, or micrometers, okay? Now, but temperature is another property of matter, or is another measurement that you're gonna be taking in the chemistry class. And in the metric system, temperature is expressed in Kelvin. Is that the system that we use in the United States? No. Here in the United States, we express the temperature in degree Fahrenheit, and in Cuba, we express temperature in degrees Celsius. The question over here is, how are we going from Kelvin all the way, how are we going from Fahrenheit all the way through Kelvin to share out data, okay, in the metric system? And the answer is simple, okay, simple. When you have, see over here, you have the first question over here. I'm gonna ignore the question for now. When you have the temperature in Fahrenheit and you want to convert that into Kelvin, you have to convert your temperature first to Celsius, and then you go from degree Celsius to degree Kelvin. How you go from Fahrenheit to Celsius? The answer is simple. You go from Fahrenheit to Celsius using the reference sheet. Okay, Fahrenheit all the way through Celsius. Remember that you want Celsius, you have Fahrenheit. You're going to use the formula. Okay, later you have the temperature in Kelvin and you want to convert that into Fahrenheit. You have to do the opposite. You convert the Kelvin into Celsius and the Celsius into Kelvin using the second formula that you have over here. But Ramos, you are talking too much, but you're not showing us, please, how we're gonna perform these conversions. Okay, easy piece, okay? That's why I'm gonna start with this first problem that you have over here. This first problem, okay, you were asked just to convert, okay, this temperature that you have over here in degrees Celsius into Fahrenheit. Why? Because let's say that you were born in the United States And that temperature in Celsius is not telling you anything. Remember that the point here, when you are measuring physical property, the point is that you have an idea what you're doing. Negative 38.87 maybe for you, see, that's not telling you anything. Okay, I know because I'm familiar with the Celsius scale that the temperature is too cold, but maybe you don't know that because you are used to the Fahrenheit scale, and that's why you're gonna convert that to the Fahrenheit scale to make a decision. Let's say that you're gonna make a decision. What is your first step? Your first step is just to write the formula. The formula is coming from where, mi ramo? Easy piece, okay? From the reference sheet. You have the temperature in Celsius and you want that in Fahrenheit. So you have to look at the formula. Which one am I going to use? You have to analyze. What do you have? I have degree Celsius. So I'm going to look at the formula that has a degree Celsius inside the formula and is giving me as the output the Fahrenheit. So this is the one that I'm going to use. Okay? So going back to my problem. Oh, is the problem. Okay. I'm going to write over here my formula. The formula is that to convert Celsius to Fahrenheit, I need to add 32. No, I'm sorry. I need to multiply. I need to multiply by 1.8 and I need to add 32. My second step, I'm going to evaluate the formula. So I have the temperature in degrees Celsius, that's a negative number, 87 degrees Celsius. I'm going to multiply that by 1.8 and then I'm going to add 32. Calculation, you're going to use a calculator. When I perform all the calculation, the answer is negative 35.506. And make sure that you are expressing that in the correct unit of measurement. So you're converting Celsius to Fahrenheit. You have, okay? Now, every time that you are performing temperature conversions, make sure that you round to the nearest hundredth, which is the second place. Do you have to write the final answer in scientific notation? No. Okay? For temperature, that's not needed. So the final answer here is the melting point of mercury is negative 35.51 degrees Fahrenheit. See that? It's not complicated. I'm going to use this second problem just to go all the way. I know that over here it says that you need to go from Fahrenheit all the way through Kelvin. But I'm going to use this example to go from Fahrenheit all the way. See, over here you have Celsius. You have to convert that into Celsius. But I'm going to use this example to go all the way through Kelvin because I want you to get familiar with the process. In case that, I decide to put that on the test. So now we're going to find the body temperature that is given in Fahrenheit, and we're going to convert that into Kelvin. How are we going to do that? Simple. My first step is always to write the formulas that I need to know, that I need to use. Okay? If you look in your textbook, you can convert from degrees Celsius to Kelvin by adding 273. But in order to convert into Kelvin, you need the temperature in degrees Celsius. So how are you going from Fahrenheit all the way through Celsius? One more time. Reference sheet. Reference sheet. Ms. Ramos, are you going to give us the reference sheet? Yes, I'm going to give you the reference sheet the day of the test, because otherwise it's going to be impossible for you to solve this type of problem. And from the reference sheet I have that if I want the temperature in degrees Celsius, I have to subtract 32 out of my Fahrenheit, and then I have to divide by 1.8. See, I'm not inventing that. Not inventing that. Is a given that you have over here. You don't have to memorize. It's a given that you have in your reference sheet. Okay, so going back to my problem. Now that I have my two formulas, see, I know that I have the temperature in Fahrenheit. So first, I need to convert my temperature into Celsius, so then I can use the second formula and convert the Celsius to Kelvin by adding 273. And I'm going to start with the first formula. Okay, so I have 98.6 degrees Fahrenheit. I'm going to subtract 32, and then I'm going to divide that by 1.8. And remember that if you don't know how to subtract, add, divide, and multiply, you have a calculator, okay? When you plug all of these numbers inside the calculator, the answer, 37 degrees Celsius, meaning that you went from Fahrenheit all the way to Celsius. Are you done? No, because you want the temperature in Kelvin. Remember, when you're completing your table to share the results, you need to express all the numbers in the Kelvin scale. This is an example that I'm using. That doesn't mean that you have to convert, for number 2, that you have to convert the temperature to Kelvin. I'm using this problem as an example, see, to show you how to go from Fahrenheit all the way through Kelvin. Okay, so I have Kelvin over here, and I'm gonna add my degrees Celsius plus 273. That's gonna be equal to, 10, 11. If I don't make a mistake over there, when you add 37 over here, 10, and I need to add 1, see? 10 and 1, 11, and I need to add 1 over here. So in 37 Celsius, you have 310 Kelvin, okay? Which is the temperature of the body expressed in the Kelvin scale. Ms. Ramos, what's going to happen if we have the temperature in Kelvin? We have to go all the way through Fahrenheit to understand or to make sense of whatever data we are reading in there. You do just the opposite. You subtract 273 from your Kelvin, and you have that in Celsius. And then you apply the formula to go from Celsius to Fahrenheit. With all this information and the information that you have from the past video, I'm pretty sure that you're gonna be able to perform any temperature conversions, meaning that I'm not going over that topic anymore. You have to sit down, quiet your mind, and watch this video and the other one that I was showing you as many times as needed, okay? Because today you have 1 hour and a half to go over all this material. Okay. This is another topic that I was teaching you last week, but I want to go over that one more time because some of you were having difficulty when you were completing the homework. Guys, knowledge is not going to come to your brain by osmosis. That's not going to happen. That's what I'm creating all these videos. Now you have resources posted online that you can use to learn. Okay. This is conversion between systems. Why conversion between systems, Ramos? Okay. Because you are jumping from one system to the other. You're not converting within the metric system. No. You're not using mnemonics. Okay, you are jumping from one system to the other. How do you know that given equation? Simple. It says over here, how many liters are there in 8.75 quarts? Okay, so that means that I have 8.75 quarts, and I want the same amount in liters. So you're gonna repeat that for yourself. Quarts, liters, quarts, liters. Do they have a word in common? No. So I don't need to use the mnemonic. Remember that King Henry died drinking chocolate milk? No. Over here, that doesn't work. Okay? So quarts, liter, they don't have a word in common. Boom. I have to use the reference sheet. Okay? So if that's your first step, find the conversion factor. Where are you going to find the conversion factor? In the reference sheet. Okay, Ms. Ramos, I'm going over here. And according to you, we were converting between system. Okay. When I was analyzing my problem, I was going from the customary system to the metric system. So I'm going to look over here in this place, a conversion factor that is relating me quarts to liters. Okay. And I'm going to start looking over here. I have inches to centimeter, but I'm not measuring length, Ms. Ramos. So I'm not going to look over here. So let me move. Oh, I have over here that 1 cup is equal to 0.24 liters. Can I use that? Yes, you can use that. And I have over here that 1 gallon is equal to 3.785 liters. Can I use that? Yes, you can use that if you want to, as long as later you're setting that up properly. I'm going to use the first one, okay? Because that was the first one that I saw over there. And it has liters. And I want the final answer to be in liters. So I'm going to put it over here in my problem. In 1 cup, see, my conversion factor. In 1 cup, I have 0.24 liter. Oh, Ms. Ramos, we have a problem. The given is not in cups, it's in quarts. What am I gonna do? Okay, now you have to do to this part of the table conversion within a system, because cups and quarters, they belong to two units of measurements to express volume in the customary system. So I'm gonna look on this side over here. And it says over here that, okay, I have cup over here, okay? And 2 cups equal to 1 pin. But I don't have pin. Pine. I don't have a pine. Pero aquí dice que the 2 pines, they are going to be equal to 1 quart. Can I use that? Yes, you can use that. So now you have another conversion factor in which you have cups, but you don't have quarts. But then you have another conversion factor in which you have quarts, but you don't have cups, but they're related. Okay? Because you have cups, so you have to go the way through cups. Pero 2 cups all the way through. A ver, let me see. A ver, cups all the way through. Y let me see what I have. Because I have, within the system, you need to look for conversion factors that are relating whatever you have at the beginning, which is quarts, with the conversion factor that you were using to go from one system to the other. Okay? So I'm going to use that. 1 pint, 2 cups. Okay, 1 pint is equal to 2 cups. And what is the other one? 1 quart. Let me write this over here. 1 quart is equal to 2 pints. And now I have 3 conversion factors. Is that okay, mi Ramos? No problema. That's all okay. Why? Because you have your liters that you need, and then you have over here the quarts that you need. See? It's all in there. After I have my conversion factors relating every unit of measurement, mi Ramos, what is my next step? You have to set that up. Set that up. Always you're going to start. See, that's step number 2. Set that up. Always you're going to start with whatever you have. And you have quarts. Okay? You're going to put it over 1. Always you're going to multiply by a conversion factor. And this is when you have to pay attention. Okay? Because you're going to put a line and then you're going to analyze. If I want to get rid of the quarts, do I need to put the quarts in the numerator or the denominator? If the answer is in the denominator. So I'm going to look at the conversion factor that has a quart in there. In 1 quart, I have 2 beans. 2 pints. Okay? And I'm going to cancel the quarts. See that? But I don't want this. No way, Jose. I want my final answer in liters. So I'm going to multiply by another conversion factor. Another. If I want to get rid of the pints, what do I need to put the pints? Numerator or denominator? Of course, pints in the denominator. 1 pint, 2 cups. See that? Yeah, I'm going to cancel the pint. Meaning that I have the final answer in cups. But I don't want cups. No. I want liters. So I need to multiply by another conversion factor. But if I want to get rid of the cups, where do I need to put the cups? Numerator or denominator? And you know that denominator, so I can cancel that. In 1 cup, I have 0.24 liters, and if you can see, the cups, they cancel with each other. So I was getting rid of the quarts, I was getting rid of the pints. Now I'm getting rid of the cups, and the final answer is going to be given in liters. That technique that I just used, multiplying by conversion factor after analyzing unit of measurements, is called dimensional analysis. And we're going to be using that technique during the entire school year. Okay? Entire school year. Miss Ramos, how are we going to solve all of this? Easy piece. Okay. You're going to multiply numerator times numerator. And then you're going to multiply denominators times denominators. And then you're going to divide. Oh, Miss Ramos, the question that we have. Always we're going to have ones in the denominator. No. It depends on the conversion factor that you're using. Okay? For example, over here you have another conversion factor that has liters included. See? 1 liter is that many, 1 gallon is that many liters. And over here, you have another conversion factor that was relating gallons with quarts you can use. Okay? So in that case, if you were deciding to use those 2 conversion factors, that 4, see, since you want to get rid of the quarts, the 4 goes in the denominator. Okay? Yeah, I'm not going to do that for you. Just try to use those other 2 conversion factors and set that up, and you will see. Then you're going to end up with different numbers, numbers that are not ones in the denominator. Now, solving this, I know that my denominator is 1. I know that the unit of measurement over here that is left is liter. Now I'm going to multiply 8.75 by 4 and then by 0.24. After multiplying all these numbers, I got this. liters. And that's your final answer. 8.4 liters in there. Final answer. How many? There are 8.4 liters in 8.75. That's your final answer. This is how you apply dimensional analysis to solve conversions between systems. You have another video posted in Schoology explaining this topic step by step. So you have to watch that video as many times as needed to understand dimensional analysis. Okay, so just let's say that you want to find the density of a given substance. Okay, so since you know how to measure the mass and volume of different substances using the instrument that we have here in the chemistry lab, you're going to be gathering data. For example, let's say that you're doing that for water. If you have 3 samples of water, you're measuring the mass. And when you're measuring the mass, you realize that you have 1.01 grams of water in your first measurement, okay? Significant figures, when you were completing the vocabulary activity, you know that significant figures are any measurements in which you're gonna list all the non-digits plus an approximated one. But when you're working with significant figures, you have to follow the rules that you have in your book. So rule number 1 that you have over here, it says that non-serious numbers are always significant. And look at the mass that you have. You were using the digital balance, and when you were measuring using mass difference, the mass of the water that you have in the beaker, that was the number that you got. Okay, so any zero that is between 2 significant figures is significant, meaning that in that measurement you have 3 significant figures. See how you're applying the rules? But let's say that instead of giving you a digital balance with only 2 decimal places, Ms. Ramos is giving you an analytical balance. You are measuring a second sample of water. But this time, you were able to find the mass of the water that you have in your second sample, but with 5 decimal places. So now you have 0.985 grams of water. See that? Now, instead of having this number over here, triple beam balance with only 2 decimal places, you have an analytical balance, and you were measuring the second sample of water, and this is the measurement that you have. But you need to find the number of significant figures, because at the end, remember, you're going to find the density of the water. You're going to divide that by the volume, and you have to express the final answer with the smallest number of significant figures. Ms. Ramos, but how many significant figures do I have in there? You're going to look over here, see? Placeholders, zeros, they are not significant. Okay, to remove placeholder 0, you have to write the number in scientific notation. In this case, after the decimal point, any number that you have over there, they are significant. In this case, you have 4 significant figures in there. Significance. If you are unsure where you have situations like that, then you write the same number in scientific notation. Now, what happened with the decimal point? That anything that you have at the decimal point is significant. So let's say that instead of a significant figure, you have a digital balance or an analytical balance with this precision. If the 0 is after the decimal point, that 0 is significant. But let's say that you have this situation. This 0 is a placeholder, so that 0 is not going to be significant. In case that you are unsure if the 0 is significant or not, because it's after the decimal point, okay, but all the way through the left, you don't have any other number between the zeros, okay? If you are not sure what do you have to do, just write the number in scientific notation. That's how you apply the rule for significant figures. Why significant figures? Remember, if you want to find the density or you sample the water, at the end you have to express the density with the less amount of significant figures. So let's say that over here you have another reading with four, let me see, 1, 2, 3, 4 significant figures. If for that amount of mass, the volume of the sample of water was 0.970 milliliters. Okay, so over here you were measuring the volume with a very precise graduated cylinder, and see, okay, over here you have 1, 2, and that 3 that you have there is significant. So you have 3 significant figures. Now that you have the mass and that you have the volume of your third sample of water, you need to find the density. But when you are expressing the density over here, you have to express that with 3 significant figures. When you are dividing the mass, by the volume, mass was expressed or was measured, and the measurement was given using 4 significant figures. By the volume was measured, and when that data was expressed, the value has only 3 significant figures. So when you divide the two numbers to find density, you have to express that with the small amount of significant figures. And that's why you need to express the density with 3 significant. When you divide these two numbers, to find the density, if you use a calculator, you're gonna get this big number. Well, not big number. It's not a big number, but it has a lot of decimal places. Miramo, do I have to round to the nearest 100? I don't have to tell you anymore, because now you're gonna use the concept of significant figures to do that. Okay? Since you have to express the final answer with 3 significant figures, you have 1, 2, 3. So you're gonna look at this number over here. It's bigger than 5, so you have to round that grams per milliliter. And here you have the density of this sample of water, okay? This sample of water expressed with a correct number of significant figure. 1, 2, 3, 4, 1, 2, and 3. So the final answer with 3 significant figures, 1, 2, 3 significant figures. And that's how you apply the rules of significant figures when you're working with numbers. Ms. Ramos, what are we doing all of this? Because remember that you are in a chemistry lab. And in the chemistry lab, when you are measuring physical properties like solubility, pH, density, see? When you are measuring physical properties, you're going to make mistakes. And the cause of the mistake, they can be different, okay? Maybe the equipment is not working properly, or maybe it's because you don't know how to use the equipment, okay? But you need to find the error. You need to find the error that you make, because based on that, you're going to analyze the accuracy and precision of your data. Remember, we're in the chemistry class, and in the chemistry class, you have to be precise and accurate. Okay, now how are you going to calculate the error of your data? Error is simple. The error is the difference between the experimental value. Ms. Rami, what is the experimental value? The experimental value is the one that you were measuring, or the one that you were calculating as the sample with density, minus the accepted value. If the accepted value always is a given, I'm going to give you that, or you're going to have some reference in which you're going to have the acceptable value. The acceptable value for the density of water is 0.98 grams per milliliter, okay? When you were calculating the density, remember, since we have to express that with 3 significant figures, when we divide the mass by the volume, we have this number. That was the number that you calculate, which is the experimental value, because you were measuring the mass and the volume. I'm going to subtract my 0.98 just to get my error. Why, Ms. Ramos? Because with this information, then I have to calculate percent error. Okay, Ms. Ramos, the error always is going to be positive. No. In this case, you have the experimental value is bigger than the accepted value, but you're going to have some cases that the experimental value is going to be equal to, or no. a negative number because the experimental value was a number smaller than the accepted value. When you input this number in your calculator, the error in this case was equal to 0.05 grams per milliliter. What are you going to do with the error? Nothing. The error is the first step when you are calculating percent error. Percent error. If the percent error is going to be equal to the absolute value of the error, absolute value of the error divided by the accepted value, multiply by 100. Okay? In this case, you have that the error was 0.04 grams per milliliters divided by my accepted value is 0.98 grams per milliliter. I'm going to cancel the units and I'm going to multiply that by 100. Why the percent error is so important? Because the percent, in order for your data to be accurate and precise, that percent error has to be smaller than 5%. After measuring a physical property, you calculate the percent error and the percent error is bigger than 5%, you have to go back and measure that again because that means that you make a lot of mistakes and that value that you got after experimentation is not correct. So you have to go back to do what you were doing before or you have to check the instruments because the instruments are not working properly. Okay? So if I put all these numbers inside my computer, if I put all these numbers, if I divide 0.04 by 0.98 and multiply that by 100, I'm going to get this number, 4.08163265%. Mi Ramo, do we have to round to the nearest 100? I don't have to tell you that because I was teaching before how to work with significant figures. 0.04. All the zeros, they are to the left. Okay, they are placeholders. So I have over here one significant figure. 0.98. 0.98. See? 1 and 2 significant figures. So I need to express my error with the smallest amount of significant figure, meaning that I have to express that with one significant figure. If I do this, percent, see, 4.08, I have 1, 2, 3 significant figures. So I'm not expressing the final answer with the correct amount of significant figures. Okay, so if I do this, I have 1 and 2 significant figures, and I need only one significant figure for my final answer. How are you going to do that? If you do this, if you look at the rules, this is a counting number that have infinite significant figures. So if I want to write my error with the correct amount of significant figure, this is the way that you're going to do this. 4.4 infinite significant figures. 4 point, over here you have one significant figure, percent. If this is your final answer. Super important. Why? Because let's say that you have to take a test, okay? And in the test, I'm going to give you all these answers, but all of them, they're incorrect because you have to express the final answer with the correct number of significant figures. Hopefully, after this video, you're going to be able to complete the assignments that you didn't complete last week. So you have to complete the understanding main ideas, following this example, okay, paying attention to the significant figures and writing the final answer with the correct amount of significant figures, and you're going to be able to find error and percent error for the problems that were given in that understanding main ideas questions. In addition to that, make sure that temperature conversion and other conversions are done and submitted, because otherwise I'm going to put a sit on the grade book and an ugly comment, okay?